Okay, guys, welcome to 26.2. Today is kind of a long lesson, but hopefully I can talk fast and make it not quite so long. Because I want to make sure I teach it well, because this is a really important lesson. It's about quadratics and square roots and how they're inverses of each other, and how you have to restrict the domain of the quadratic to match the square root. So it says all functions have inverse relations, but the relation may or not be a function. So remember, a relation is a set of points, like a scatter plot. So that doesn't have to be a function. But a function is a relation, because like I just said, a relation is just a set of points graphed. And sometimes it makes a shape a function, sometimes it doesn't. It's just a vocab lesson. Okay, this one says use the quadratic function, graph the inverse of g. So what I would do is just pick up the points. So remember, you just switch x and y to graph the inverse. So this is the point 0, 4. The inverse point would be what, 4, 0? That's what I would do. And then let's do another one. Looks like 2, 8. So let's do 8, 2. And then 8, negative 2 is probably the other one. All right, so just switch x and y. Now we've graphed the inverse function, or the inverse of the function, I should say. So these are inverses of each other. Just switch x and y. You can draw the line y equals x if you like. You can see how it's reflected, all that good stuff. Okay, then it says, is the inverse of g a function? Well, this is a function, but is this? And hopefully you'll say no, because for every x, there is more than one y. Okay, so for every x, there is more than one y. Okay, this is what I want to see in your homework. I want to see this kind of answer, because this tells you why it's not a function. Okay, most of you are probably going to say, oh, it's not a function because why? It fails the vertical line test. Okay, so this is my expectation of you. Okay, so failing the vertical line test is just a test. It doesn't tell you why it's not a function. It's just like, hey, it failed the vertical line test, so it's not a function. So a good reason to say why this is not a function is because for every x, there is more than one y. That's why it's not a function. But if you want to say in your head, you want to make sure that you're right, you can say, hey, it fails the vertical line test. Then you could say that, but that's not a good explanation. That's just a test. You could also say x repeats, right? If x repeats, it's not a function. Some of you might be saying that. X repeating would kind of go with the explanation. For every x, there's more than one y, so x repeats. So, and when you get to pre-cal, filling the vertical line test is just a test, not an explanation. Okay. Then it says, which characteristic of the graph of a function can you use to determine whether its inverse relation is a function? You could say what we just talked about here, the reason why. Because there's two of the same y value. Y repeats, right? So since you have two of the same y value, then therefore it's not a function. Give the domain and range of the inverse relation in part A. So what is the domain? So this is the inverse right here, right? That's the inverse function. So it says give the domain and range of the inverse relation. So let's do the inverse one. And you notice the word relation. It's a relation because this is not a function, because it has more than one y value for every x. So the domain of this one is x is greater than or equal to 4, which I know you guys are good at this. Or you could say 4 to infinity. Or my favorite, you could say x such that x is the element of the reals, where x is greater than or equal to 4. So let's remind ourselves. This is the inequality notation. It's been a while since we've done this. It's been so long. This is interval notation, and this is set notation, right? Interval, inequality. Okay, so those are different notations. That's good to know that. Definitely for pre-cal. And then the range is what? Low to high. So you can tell with the double arrows. Double arrows means at least one or both of your domain and range have to be all real numbers. Has to be. So this one would be negative infinity to infinity, or some people say all real numbers. So don't forget that. So whenever you have double arrows, you know one or both have to be all real numbers. Okay, one down. Let's move. Let's keep moving. All right, next page. It says, let y represent g of x. Okay, see, it says the quadratic function shown in the graph in item 1 is x squared plus 4, because it went up 4, didn't go left to right, stretch or compress. So this is the question, x squared plus 4. And then it says find the inverse. So you can tell they switched x to y, they solved for y. Now this is really important, and this goes back to what I retaught that one lesson a couple days ago. When you solve for y, that's when you do the plus or minus, right? That's when you do the plus or minus, when you're solving for y. So really, really important right here. Plus or minus. So important. So important. Plus or minus. It says when taking the square root of a variable, the result yields in a plus or minus. Oh yeah, all this whole box is awesome. Okay, so let's think about it. Let's go up here. So y equals square root of x. So we all know that that graph looks like this, right? I know you guys all know. Looks like starts at 0, 0, has that kind of shape. But when you're solving and you get plus or minus x, that's going to look like this, right? You'll have like this part will be the plus part, and then this part will be the minus part, like that. So square equals square root of x, this is the parent function right here. Okay, we all know that. We're good at that. But this plus or minus, I'm going to put an arrow down here. This plus or minus means you have the plus square root and the negative square root. Therefore, that's how you get that sideways parabola to match the original function. So here, this is a parabola, right? And this would be the sideways parabola, and this is y, because you take the plus or minus. Okay? Let's keep moving. It says, find the inverse of the function y equals, say whether or not the inverse is a function. Okay, so let's do that one. Let's do letter A. So it says, so obviously switch x and y. X equals negative y to the 1/2 power. So before you can get rid of that 1/2, you got to get rid of that negative first. So it's going to be what? Switch this sign. So negative x equals 1/2 power. Well, 1/2 power is square root, right? And the opposite of square root is square, or power to a power you multiply. So you'd raise this to the power of 2. So it'd be what? Negative x, make sure you put in parentheses, squared equals y. Well, we all know negative times negative is positive. So it's y equals x squared. So here is the inverse function. But this right here is negative x to the 1/2 power. So I'm going to go over here. Let's talk about that. Y equals negative. Okay, this is the same thing. So what I'm drawing right here is this right here, right? That's the same thing. I'm just rewriting with the radical. Well, let's think about this. So if I draw this graph, it's going to be 0, 0. It's the negative version, which is the negative version. So it's going to look like this. It's reflected across the x-axis, because you guys know that's a transformation. It's reflected across the x. I know you guys know that. Okay, so let's go back to the lesson from Thursday. So the domain of one is the range of the other, and vice versa, right? So we have to restrict the domain of this one, which means it has to match the range of this one, because these are inverses of each other, right? So this makes a parabola, right? This makes a parabola, right? But you can tell if this is a parabola and this is a square root, they don't match. The shapes don't match, right? So we have to make the shapes match. So you have to restrict the domain here. So on this one, what's the range? Well, the range on this one is what? Y is less than or equal to 0. So that's the range of this one, which has to match the domain of this one over here. I hope you guys get this together. Good thing I'm doing video notes. Okay, so then what is the domain of this one? So the domain of this one would be what? X is what? Less than or equal to 0. So this whole thing is the answer, right? Which means what part of the graph would you want? X is less than 0, which means you would want this part of the graph would match this part, like that. So it's kind of weird, but it's kind of like you don't want this part. You want to scratch that part out. So you only want the left side of the graph. So, and then it says state whether or not the inverse is a function. Sure, that's a function. So yes. So hopefully you guys are following the video that this A matches with these two things go together. Okay, let's switch colors. Let's try a different color. All right, find the inverse of the function of x minus 5 squared. Stay whether or not the inverse is a function. So we'll switch it really fast. X equals y minus 5 squared. Solve till you have square root. Oh, but I took the square root, so it's plus or minus. So be careful of that. Be sure you put plus or minus whenever you're solving for something and you're taking the square root of it like this. In a question, it's always plus or minus. So the final answer is what? Plus or minus square root of x plus 5 on the outside. So be careful of that equals y. So this is the inverse, right? Then the question says, what find the inverse of the function? Say whether or not the inverse is a function. Okay, so is this a function? Well, from up here, we already know, this is from this picture up here, we know this is a square root, and it's like plus, here's the plus, and then here's the minus. So is that a function? And you're going to say, hopefully, no, that is not a function, because for every x, there is more than one y. Okay. Next one, number 2. In try these part A, why is it necessary to include a restriction on the domain of the definition of the inverse? Right? So why is it important? And try this A, why is it necessary? Because the domain of the inverse is the range of the original. Hopefully you guys can read that. It feels kind of small. I'll zoom in, I guess. All right. What specific part of the question or the equation of inverse of g in example A tells you that it is not a function? Explain your reasoning. Okay. So we just talked about that. We just did that. Like in this question here, what was it? It's the same thing as this one up here. So it was the plus or minus of the square root. That's how I knew that it was not a function, because I knew this means it has two y values. Oh, wait, hold on. Two y values for x. So that's really important. Okay. Let's keep moving on. Let's see. This question says, imagine covering the right side of the graph. So imagine covering the right side of the graph. And then drawing the inverse. So I'm just going to go ahead and just cover it up. I'm just going to scratch it out like that. So it says cover the right side of the graph. Or scratch it out. Then drawing the inverse, the result would be only the bottom half of the relation inverse, which would be a function. So if you restrict the domain of g to x is less than or equal to 0, then the inverse g will be with a domain of x is greater than 4, y is less than or equal to 0. Okay, so let's look at this one. So it's saying like, okay, if you restrict, so here's a parabola, right? So it's saying like, hey, if I restrict this domain on this parabola, I'm going to say x is less than or equal to 0. So this is the original, and I'm saying I'm going to restrict the original. Well, if I restrict the original, if I restrict the original domain, will the inverse be a function? Well, this is the 0.04, so 4, 0. And we have what? Negative 1, 5, I guess, looks like. So 5, negative 1, something like that, and so on and so on. So look, so this right here, this left side of the graph, which is the negative side, is the negative side of here. So that's what it's saying. So it's saying, hey, if you take the left side of the graph only, what does it look like when you reflect it? Well, let's see. So if you think about this, here's the line y equals x, and you fold your paper, like it's kind of hard to do, but fold your paper. When you fold it over this line, y equals x, that is going to land over here, right? So if I fold my paper, this will be over there. So this is a reflection. So this left side, which is the negative side, right? Because x is negative, Remember? And so x, the inverse of one, the domain of one is the range of the other. Well, this is the negative side. Well, isn't this range? Isn't that the negative part? So the left side here matches the bottom part there. That's what they're trying to get you to understand. But instead of left and bottom, it's good to understand like x is less than 0. So this is saying like right here that the domain of this is x is greater than or equal to 4. And the range is what? Y is less than or equal to 0, which this matches. This is the domain of the original, and this is the range of the inverse. And they match. And over here, this is what the range is y is greater than or equal to 4. So it matches. So this is a function. Because you restricted the domain on the original, the inverse is a function. Okay? So let's make sure we're clear on that. So I'm going to say it one more time. So up here, this is a parabola, right? There's no restriction. So this is a parabola up here. So when I went to do the inverse, it looked like here, it looked like this, right? Hopefully you guys are following. So here, this was the original, this is the inverse. Well, these are inverses of each other because they have the same shape, you can tell, but this is not a function. So you had to restrict it to make this a function. Okay, then over here, this is a parabola, and then the inverse would be sideways. But here I restricted it in the beginning. Since I restricted it in the beginning, I don't have to restrict it in the end. So since I restricted it in the beginning, I don't have to restrict it in the end. So this is an invert. This is a function. So hopefully you guys get the two trains of thought. One, you restrict at the end because the original was not restricted. This one, I restricted in the beginning, so I don't in the end. So I hope that makes sense. If not, contact me and I will be happy to say it again and reteach it. Okay, last page. Give another example. Give another possible restriction for the domain of the function y equals x squared plus 4. Okay, so this is important to know. All right, so x squared plus 4. So here's the graph. 1, 2, 3, 4. Okay, here's a cool thing. Okay, so it says give a possible restriction on the domain of the function. Okay, so I want to restrict this domain. So you have two choices. So unless it specifies, you could do what you want. So you could say x is greater than or equal to 0, which means you want the right side, right? That's the right side. Or some of you in the class might say, hey, I want to restrict the left side. So that would be the left. So both of these are correct. You can say, hey, I want it be the left side, x is less than or equal to 0, or I can say I want to restrict the right side, y, x is greater than or equal to 0. Both of these are correct. So if it does not specify, you can restrict it either way. It does not matter. Okay, state whether the domain of each of the following functions must be restricted to ensure that the inverse is a function. Okay, so I would love for you to stop the video right here. Some of you who are self-starters would do that, and that would be awesome. So this would be a great place to stop the video or pause it. So do these 4 questions. And if I was in class, I would stop, I would walk around, I'd give you a moment. So stop the video if you would like to try it yourself. Okay, so let's do these. Number 5, do you have to restrict this? Well, the first thing I would do is go, what kind of shape is this? This is a square root. Well, we all know a square root looks like this, right? Do you have to restrict that? So state whether the domain, so do you have to restrict this domain in order for the inverse to be a function? Well, if I were to reflect that, that would just be the bottom half. So no, you don't have to restrict it because there's only one piece, one side. This one, this is a parabola, and we've been practicing this one today. So if I turn this over the line y equals x, reflected, would you need to restrict the domain? Absolutely. Okay, well, this is how you do it. You do it at the vertex. So let's do 7 right here. So if I were to graph this out, it's going to be what? 1, 2, 3, 4, 5, right? This is to the right 5. So to the right 5. So it says, which way do you need to restrict it? Well, like we just said up here, it doesn't matter. So make sure it's the vertex. You need to find the vertex, okay? Because the vertex is the turning point where it changes. So the vertex is the middle. It's where the line of symmetry goes through. So the vertex is really important. So at the vertex is where is the cutoff point, is what I would do. So then here it'd be, you could say either x is less than or equal to 5, or you could say x is greater than or equal to 5. Both of those are great restrictions. Okay, let's keep moving. This is a square root function. Y x is the 1/2 power. It just means it just shifted up 1. So it looks like this. So no, you don't have to restrict the domain. This one is a quadratic. Okay, so this one you can't tell. So it's a quadratic. So am I going to have to restrict the domain? Yes. I already know the answer is yes, because I know it's a quadratic. It'll look like that. But now the fun question is, where do you restrict it? So like I just said, you have to find the vertex. This is in standard form. So let's put it in vertex form, like that. It's going to be vertex form. So you can tell right away it shifted over 3. So this graph looks like 1, 2, 3. Looks like that. Okay, so you would restrict it at where x is greater than or equal to -3, or x is less than or equal to -3. Okay, so be sure that you find the vertex. That helps you with the restriction, because that's the middle of the graph. All right, almost done. A function is, okay, this is important too. This is in pre-cal, in calculus. You need to know this. Okay, a function is defined as 1 to 1 if for each number in the range of the function, there's exactly one corresponding number in the domain of the function. If x is 1 to 1, then it will pass both the vertical and horizontal line test. Okay, I didn't touch on the horizontal line test too much, but we can talk about that really fast. Oh, it's right here for you. Let's just read it. The horizontal line test is similar to the vertical line test. It is a visual way to determine whether or not the inverse is a function. So very quickly, we'll go over that. The horizontal line test. Here again, it's just a test. It's not a good, valid reason. That's why I guess I don't teach it too much. But it's good to check, though. It's good to know. Okay, so horizontal line test. We'll come down here really fast where it's more room. Okay, so here's a graph. I'm going to draw a graph like this. And then I'm just going to, oh no, I'm just making this up. Okay, let's just make this up. All right, so here's the vertical line test. We'll just go like this. Vertical line test, right? It hits one time, and you'll be like, yes, it's a function. Because for every x, there's one y value. Or you could say, passes vertical line test, which is not a reason, but it just helps you to say yes or no. Okay, so vertical line test is not a good reason, but it just helps you to check it really quickly. And then y is it not a function? Because for every x, y it is, for every x is 1, y. Okay, horizontal line test looks like this. Okay, horizontal line test is the same idea. Like, hits once, hits 2. Okay, it hits twice. So it's kind of like the same thought here. Since it hits twice, this one does what? So fails horizontal line test. So inverse is not a function. So let's explain that. So horizontal line test tells you whether the inverse is a function. The horizontal line test tells you whether the inverse is a function. Talks about inverse is a function or not. Not very good English, sorry. So vertical line test talks about whether this is a function, and the horizontal line test talks about if the inverse is a function. So those are the two differences. I think you learned this in Algebra 1, but I can't really remember. So horizontal line test talks about whether if the inverse is a function or not. All right, so let's see what else we got. Determine whether each type of function will always, sometimes, or never have an inverse as a function, assuming the domain of the function has not been restricted. Explain your reasoning. Okay, a line. So if you're a line, will the inverse always be a function? Sometimes, always, never. Oh, this is another good way to stop the video. So stop the video here if I were you, and then answer these 3 questions yourself. So stop the video, pause it, and then come back. Right. So is a linear is says to determine whether each type of function will always, sometimes, or never have an inverse. Okay. So a line will its inverse always be a function? And your first response is probably going to be yes, but hopefully you'll say sometimes, because if you have a horizontal line, wouldn't the inverse be this? And that would fail the horizontal line test and the vertical line test. Okay, quadratic function. Well, quadratic function, it says every one of the times I will always have an inverse. This will be never. We've been practicing that all the lesson. Square root will always, right? Okay, so let's go back to what one-to-one is. What is one-to-one? So one-to-one means that the inverse and the original are both functions. I should write that down somewhere. All right, that's what it says here. So one-to-one means the original and inverse are functions. That's what that little paragraph says right there. This is also in pre-cal, in calculus. So you want to make sure you know this language. It's vocab language. So there you go. So one-to-one means that the original is a function and the inverse is a function, which means for every x, there's only one y. And for every y, there's only one x. So for every x, there's only one y. And for every y, there's only one x. So that's what one-to-one means. That's about all I got. So you already have the homework assignment and on Thursday. So hopefully now the homework makes sense. Hopefully you guys didn't go ahead because this is kind of new. And this lesson is really important. So make sure you guys understand it. Email me, contact me, see me in Google Hangouts, and I will see you then. Have a good week.